This is a continuation of the previous video which covered the lesson simple interest and compound interest calculation. In this video, you will learn how to calculate present value and future value of investment projects. From now on, we will be using compound interest in our calculations. Recall how we calculated the balance in the account at the end of the third year after depositing $100 in the account at 5% compounding interest rate. The value at the end of the life was the future value. So this is the formula we use to calculate the future value. So in other words, future value is the value of an investment measured at a specific future date, accounting for interest earned over the life. And the process of calculating the future value is called compounding. Then how do we calculate the present value? Simply rearrange the formula so that we have present value as the subject of the formula. You will then end up with this formula. So the present value, as the name suggests, is the value today of a cash flow to be received at a specific future date, accounting for the opportunity to earn interest. And the process of calculating present value is called discounting. Okay, so here we have two different projects, Project A and Project B. We will have to evaluate these two projects and see which one's best. If you take Project A, there is a cash inflow of 5,000 at the end of year 1, another cash inflow at the end of year 2 of 10,000, and the last cash inflow is at the end of year 3, which is 5,000 again. For Project B, there are two cash inflows of 10,000 occurring at the end of year 1 and year 2. The discount rate we will have to use in this question is 10%. Someone who doesn't know finance will simply look at the cash inflows, add them up, and try to evaluate, which is wrong. So take Project A. Someone who doesn't know finance will say, okay, 5,000, 10,000, and 5,000, if you add them up, it's 20,000. For Project B, again it's 20,000 because it's 10,000 plus 10,000. Both projects are the same. That's what someone who doesn't know finance would say. But this is wrong. It gives you the wrong picture. For us to evaluate it correctly, we will have to calculate the present value. So let's do that now. Now let's do the math. We have Project A and the three cash inflows occurring at the end of year 1, year 2, and year 3. We will have to discount each and every cash flow. So the first cash flow at the end of year 1, we will have to discount it by 1 year to get the present value. So how do you do that? You have the formula. Remember, present value equals future value divided by 1 plus the rate to the power n. So it's 5,000 divided by 1 plus the rate is 10%, so it's 0.10 to the power 1 because we will have to discount it by 1 year. Then we will have to discount the cash inflow of 10,000 as well, the 10,000 cash inflow that's occurring at the end of year 2. But this time we will have to discount it by 2 years. So plus 10,000 divided by 1 plus 0.1 to the power 2 because we are discounting it by 2 years. Same case for the 5,000 that's flowing in at the end of year 3, but this time discounted by 3 years. So you add 5,000 divided by 1 plus 0.1 to the power 3. And you will end up with an answer of $16,566. Doing the same thing for project B, we will have to discount the cash flow of 10,000 by 1 year. So 10,000 divided by 1 plus 0.1 to the power 1, plus we will have to discount the next 10,000 cash inflow by 2 years. So it's 10,000 divided by 1 plus 0.1 to the power 2. You will get an answer of $17,355. Right, so we have completed the hard part. Now we have to decide. Project A gives a total present value of cash flows of 16,566. The present value of cash flows for project B is 17,355. So obviously project B is better because the present value of cash inflows is greater.